All right, so hi everybody. We're going to talk about the inverse of just a quadratic function. Now, the assumption in this video is that you have at some point gone over quadratics, and you certainly have quadratics in different forms. So for example, standard form, factored form, and vertex form. And my goal is going to be to try to kind of hint you away at how do you find the inverse in all of these three different forms. So what can you actually do? So let's do a little bit of a deja vu for inverses in general. So what do they actually mean, and what's the goal that we want? So here is a little bit of a schematic within here, okay? And we're going to start off and just assume that we have just our simple quadratic x squared. All right, so let's just start with that, and then we'll try to give other examples later on in the video where it's not just x squared. Now, the point of an inverse is that if you have an input to a function which is a quadratic, so here's our input. Now, that input, okay, your quadratic, so in this case x squared, is going to give you some kind of an output. That output is going to be coming out right here. And our goal is to try to find how do we change this particular output that we get, so right there, such that we get our input back. And that's why it's called an inverse. It means we want to reverse the process of what the quadratic actually has done. And for example, for x squared, so if I would have a table of values, and I'm going to first start with that. So let's say here's our table of values. I've only put, let's say, negative values here. So we have a negative 3, negative 2.5, negative 2, negative 1.5, and so on. We of course can do the positive ones, but because it's squared, we're going to get exactly the same values out for those positive values if you would take the absolute. Meaning, if I put 3, okay, as my input, I'm going to get 9 as my output. If I take 2.5 as my input, I'm going to get 6.25 as my output. All right. Now, so you notice that here, okay, so all I've done is really I've just taken my input, so negative 3, I've squared it, I got 9. I've taken negative 2.5, I squared it, I got 6.25, and so on. So you can see the table of values. Now, those are the values that are coming within here. So for instance, so what we have is we have this coming in here. Let me remove this. So if you have a negative 3 coming into our function, okay, and our function is x squared, which is the quadratic, then what you get is you get 9 out of here. Now our goal is to try to find a reverse, which is called an inverse, okay, if we can. So this particular function, if it exists, such that we basically get 3 back, okay? And in this case, we have, the negative 3 back, which was coming in here. So how do we do that? Well, for inverses, you may recall that really what you're doing is if you have a table of values, so in your table of values, here's your input and then here's your output, then what you would do is you just swap these. It is a swap between the x and the y, and you just swap them back, and you will get your result. Now, that's on the assumption that you have a table of values, right? That you have ordered pairs. So for instance, okay, so here my swapping back, so what I would have gotten is 9, and then that would swap back for me and give me negative 3 back. So here what I am inputting is f of x, which is right here. That's the result. And then I'm going to get negative 3. So here, 6.25 is coming in, and what I get is negative 2.5, and so on. So really what I'm doing is I can just copy these down. Okay, so I can take these, duplicate it, and put it in here. These are my new inputs to my inverse. And then my outputs are going to be just the values that I have for my original input that I got. So they're just swapped. Now, we can graph these, and of course, we can also graph the positive values, okay, of all of these. I'm going to do that on decimals so that we can see it. All right. Okay, so give me a moment. Okay, so I'll prepare that for you. All right, so welcome back. So what I did was, so on the left-hand side, you'll notice that I've inputted, a few things, but we'll take it one step at a time. So what I've done is on the blue that you see there, so those are the points that I have. So my input, so -3, I get 9, -2.5, I get 6.25. So I've just plotted the points in decimals in here. And then I put the positive ones, and you can see them in red there on the right-hand side. And it creates a nice parabola for us, right? So I didn't have to do this. I could have just plotted the entire parabola, right? X squared, and I would have gotten this, right? So I'm going to remove this parabola for a moment. And now for the inverses, so if I go back here into our picture for the inverses, well, everything was swapped, all right? And here I just had the negatives. So maybe let me just work on the negatives for the moment. So let me go back here. I'm going to remove the positives. So if I put in the negatives and then just swap them, so I'm going to put them in here, okay? So this is what I get. So notice, okay, so what happens is, okay, so those negatives, okay, so if I'm going to have to kind of squeeze them in here a little bit. They're basically just a reflection, and for all inverses, they're always a reflection along the y is equal to x axis. So if I would plot y is equal to x, you'll notice that it's symmetric along that line, right? Now, these are only for the negative inputs. And so if I would graph this out, okay, so with regards to, okay, our parabola, so this is the first half of the parabola. And now if I put in the actual inverse, okay, so the inverse points within there, then what you would notice is that you have something like this, right? And this would have been your actual true inverse. Now, that is done through just points and then graphing the points through them. But as you can see on the left-hand side, I have a square root of x. Now, where did that square root of x come from? Or where did the square root come from anyways within the inverse? And so please remember, okay, so if you are trying to find an inverse without actually using a table of values, as we did within here, so if we were given, so I'm going to just write y is equal to x squared. So I'll drop the f of x and just simply say and make a relation instead of just a function within here. So if you want to be able to find the inverse, well, we said we're swapping the x and the y's. So what you have to do is whenever you're given a quadratic, you really have to swap these, okay, and solve. Instead of having y is equal to x squared, you want to be able to solve for x and then swap the variables over to get the inverse. I just want to show you that what happens within here. Well, if I want to be able to swap that, then I'm going to be taking the square root. So I'll take the square root of both sides and I'm going to get this, which means that my inverse is that. But of course, so right here, so this x and the y, well, we were swapping those. And if you're going to be swapping those two, so this is going to look something like this. And that would have been now your inverse, which is your square root. Now, whenever you're taking square roots, you might say, but wait a minute, when you take a square root, aren't you supposed to take both positive and negative answers? And that is true. You are supposed to do that, okay, if you're doing just arithmetic. Unfortunately, okay, if you do that, your inverse, which is indeed this, both for the positive and negative values for the input, will no longer be an actual function. Now, why not? Okay, so if this is supposed to be my inverse, okay, so if this is supposed to be my inverse, and we designate the inverse with the little -1, okay, kind of as an exponent. It's not an exponent, it's just telling us in math that we're talking about an inverse. If you do that, let me go back here to decimal. So if I plot both the positive and negative sides, so notice here's my parabola, original one. We'll put the points there on as well. And now, if I put both the negative and the positive sides, okay, of all of that, I'm going to remove this y is equal to x because I don't want it too cluttered. Okay, so this is what we have. So my parabola x squared is a nice, beautiful parabola. And then my inverse is a parabola, but it's, kind of shifted or basically reflected along the y is equal to x. What's the problem with this sideways parabola. The problem is it's not a function. Because you will notice, so for instance, for 4, okay, so if you take x is equal to 4 for the inverse, okay, you'll notice that you have two values. You have 2 and you have -2. And that would make it not a function because you have more than one value, okay, for your output within your inverse. So typically what we do is, okay, if you're going to want to have an inverse, you either are going to take the left-hand side or the right-hand side of the parabola, which then is going to be restricting your inverse. So if I only take the left-hand side of the parabola, so let me remove the right-hand side. So I only have that. Let me remove those points. Okay. So if I do this, and then the other points I'm going to remove as well. Okay. So on the left-hand side, the inverse is indeed the square root. But notice the inputs that we had to the original were only negative. Now the inverse, which is the square root, but it's the bottom square root that you see there. Now it is a function because it doesn't have multiple outputs for that. So you can do this. Or you can restrict it in the other way. So if I would remove this and I would put all positives, okay, so for instance, I would do that. And here is my positives. I'm going to remove those. Now in this case, okay, so what we have is, now we have both. And let me make sure that I have this correctly within here. So there we go. These are the positive inputs. And then this would have been just the square root of x as your inverse. Now this inverse does exist as a function, okay, because it only has one output, okay, for each input that we have. So you have to be careful with quadratics, okay? So the parabolas aren't an issue because all parabolas are going to be functions. They only have one value. But when you're taking the inverse, you have to be careful. So you're going to have to restrict, so you only take kind of one full side of that. And that will depend, okay, on the actual questions that you're working with that you'll have. Let's take a look at a few examples in these quadratics so that you can see how to find these inverses without a table of values, but just simply solving this. So here's my first example to you. Okay, so this example is in vector form. Okay, sorry, in vertex form. So this is in vertex form. So if you remember, the vertex form, okay, is a and then x minus h squared plus some k. This is your vertex, the h and then the k. This is your a, so we know how the parabola opens up or down. And if you have a quadratic in the vertex form, that is the best thing that you can actually have because you can solve directly for the inverse. And I'm going to just show you how. So in order to solve for the inverse, I'm going to write y instead of h of x. So we have this. We are trying to solve for this x. That's what we're trying to do. So if I want to be able to solve for that, I'm going to be moving this -4 on the opposite side. So y is going to become plus 4 equals negative. This is going to be x plus 1 squared. Now I'm going to be dividing by this -1. So that's going to give me, so y plus 4. Okay, so that negative is going to switch over on the other side. Now that we have that, now we can take the square root of both sides. So if I take the square root of both sides, I'm going to get square root negative y plus 4 is equal to x plus 1. And now the final step is I'm just going to shift this over on the other side. So what I'm going to get is this. Okay, and then it's going to be -1 is equal to x. And just as in the previous example, we have to swap the x and the y so that we actually get our inverse. All right. So now our inverse, what we have within here, so I'm going to write it. So our inverse is equal to, and now if I'm going to be swapping those out, it's going to be negative and this is going to be x plus 4 minus 1. All right, so this is how it would look like within here, but we have to be careful, right? In reality, what we have is this plus or minus, okay, has to be there. However, okay, if we graph both plus or minus within here, then we're going to run into a problem and it will no longer be a function. Let's try to show that on Desmos so that you can see this kind of visually and then compare the actual inverse and then what restrictions would we have to put in here. The other problem is, okay, what you will find is that we cannot have under a radical, this can never be negative. So we will have restrictions here right off the bat, okay, because we cannot have this under the radical to be negative. So this right there has to be greater or equal to 0. All right, so this has to be greater or equal to 0. Now this has to be greater or equal to 0. And when does that happen? Okay, so we're going to be taking a look at that. All right, so here is our parabola. So it is pointing downwards, all right, in this particular way. And now let's try to see if we can plot the inverse, okay, so for this. So we're going to try to do that as well. All right, so now here's your inverse. And you'll notice that what Desmos will do is it's going to take the positive value of that square root. And it's going to only have one of the halves. And if you want to have the other half to try to graph it, but if you do graph it, then it's no longer a function, right? So here is, you have to put both positive and negative, okay? So the first one, okay, the one on the left-hand side, as you can see there at the bottom, the H, okay, is the positive side, that's the purple, and then the black one, the G, okay, I put the negative in front of the square root. And you will notice that there is indeed a restriction, right? We have no values at all, okay, to the right-hand side of negative 4. And that is because, so if you recall within here, so what we did was, we said we would have a restriction right here for our x. So our x, okay, so or negative, okay, x plus 4, in brackets, there has to be greater or equal to 0. And this only happens, so if you solve this, okay, you will find that x is going to have to be less than or equal to negative 4, okay, if you would do that. And that's exactly what Desmos has done here for us. So is this a function? Well, if you plot both, okay, if you do both the positive and the negative, so right here, so if you take both of these, unfortunately, it will not be a function at all. Okay, so you either have to take the positive or the negative depending on the problem that you're facing. So that's what you have to do. Okay, but in order to solve it and isolate when it's in vertex form, then it works very, very well for us because we can actually do that. Now, in this next example, so what I'll show you here, this one is in factored form. And in factored form, notice there's two x's there, right? Because they're part of the two different factors. This is still a quadratic. Now, what I recommend is always try to put it into vertex form first. And then when you have it in vertex form, then it's very simple actually to isolate for your x. And you will get square roots, but it is definitely doable. So for this example, what we would have to do is the following. So I would have to first expand this entire thing out and try to obtain its vertex form. So I'm going to do that, all right, kind of step by step. I'll put it in fast forward fashion, and you can look at it and slow down if you like. All right, so this is now in standard form. And now from standard form, we're going to complete the square and we're going to get the vertex form. Okay, so let's do that. All right, so it took me a little bit of time, but here is your vertex form. Now, once you have this vertex form, now you basically try to solve and isolate for this x. And then you swap your x and your y, and you will have your inverse. So whenever you're facing these quadratics, if they're in vertex form, amazing. If they're not in vertex form, then put them in vertex form so that you can try to isolate and then find the inverse itself. And then you're going to put the restrictions depending on what you would like within the question. All right, so the goal is to try to change these back. So that's what I'm going to do next. I'll call this y, and we're going to solve and isolate for this x, okay, to get the inverse. All right, so here we have it. Notice that it's super ugly. Most likely, you would try to simplify this, maybe as much as you possibly can, but I just left it because I didn't want to kind of skip some steps within here. This positive or negative, again, you're going to have to pick either one or the other. You can't pick both, because if you do, you will no longer have a function as your inverse. Okay, so just keep that in mind. And this, what I highlighted here, okay, in yellow. So we would try to set that x minus 1 over 4 all over this, negative 4. This has to be greater or equal to 0. All right, so you would have to do that in order to try to see, okay, so what we would have within here. Okay, and then once you have that, that's going to be a restriction. Okay, and then again, you pick either the positive or negative. So again, steps are put it into vertex form, isolate it, swap your variables, x and y's, and then you have your inverse. And then you can go from there depending on the restrictions that you need. All right. So that's pretty much it. Of course, you can run into many other quadratics, but this is what you will see. So if it's in standard form, okay, put it into vertex form. If it's in factored form, put it into vertex form. If it's already in vertex form, okay, then it's one step less for yourself. And this hopefully gives you some ideas. And of course, now that you do have tools like Desmos, you can plot these out. And once you have them plotted out, you can see if there's a nice reflection along the y is equal to x. So quadratics and finding their inverses is definitely possible, and I hope that this has given you some a little bit more maybe insight, and definitely try these for practice. All right, thanks for watching. We'll see you in a future video. Bye everybody.